For those of you who don't know, my job as Deputy Assistant Secretary for Operational Energy really looks to improve the way our aircraft perform from both a procedural way, so we spend a lot of time working with pilots and crews on more effective and efficient way of executing the mission, to include planning tools, that type of stuff. And then the other piece that we work on is on technologies like this technology that we're going to talk about today. Just a quick introduction of the folks on the stage here. Mr. Dan DeSilva is the President and Chief Operating Officer at JetZero. Dan is an aerospace engineer and is responsible for engineering, product development, program management, supply chain, manufacturing, quality, and R&D operations. Prior to joining JetZero, Dan worked at several aerospace companies in a variety of roles during his 35-year career. He started as a flight test engineer at Embraer in Brazil, then moved on to Douglas Aircraft Company in Long Beach, where he held positions such as performance engineer, marketing analyst, and eventually aircraft sales director for all of Latin America. After the merger with Boeing in 1997, Dan moved to Seattle and soon became vice president of airplane sales for Latin America. After that, he worked program management for modifications and upgrades, aircraft finance, strategy, and policy, and is a member of the board of directors for Aviation Partners Boeing, or was a member of the board of directors of Aviation Partners Boeing. Okay, next is Sangeeta Sharma, Director of Sustainability Skies Lab at Delta Airlines. The Sustainable Skies Lab is the first of its kind airline innovation lab to accelerate research, design, and testing for a more sustainable future of air travel. Sangeeta spent 10 years at Delta, where she's held roles across the operating business units, leveraging data to ask questions and drive innovation, process improvement. In that time, she has developed a roadmap to using advanced decision science across operations, reduced airport process seams with joint venture partners, and fostered enterprise innovation as a founding member of multiple internal business resource groups. Sangeeta earned her BS in aerospace engineering from Georgia Tech, as well as an MBA from Emory University. Next is Mr. Stan Tran, Senior Manager at United Airlines Ventures, a corporate venture capital fund started by United Airlines to invest in emerging companies and technologies that have potential to disrupt the end-to-end travel experience and lower the aviation industry's carbon intensity. His primary responsibilities within the UAV team include the development of advanced air mobility concepts and evaluation of venture investment opportunities in the airframe and airline technology sectors, including leading UAV's investment in JetZero. In addition to UAV, Stan also focuses on corporate development initiatives for United Airlines. He previously worked international route planning, capacity strategy, and new route launches for transatlantic. Prior to United, Stan spent 7 years on Wall Street working as a high-yield debt analyst for New York Life Investment Management, a subsidiary covering aerospace and defense and airline sectors. Stan received his BS in Business Administration from Boston University with a minor in political science. Okay, and finally, we have Mr. Greg Norris, President of Scaled Composites. Scaled Composites focuses on pursuing cost-effective development projects delivered on a short schedule. Mr. Morris joined Scaled as president in 2023 and is checked out as a test pilot for Scaled's agile, responsive, effective support demonstration aircraft, as well as the Model 401 Sierra. Prior to Scaled, Greg was president and chief test pilot for Gauntlet Aerospace. He is also an associate fellow of the Society of Experimental Test Pilots and serves on the SETP membership committee. As a nationally designated FAA experimental examiner, Mr. Morris has conducted check rides for a variety of aircraft, including AlphaJet, L-39, and Scaled Composites Proteus aircraft. Greg received his BS in aerospace engineering from the University of Southern California and an MS in flight test engineering from the National Test Pilot School. Okay, now that we've introduced our folks, I'd like to initially just start giving a brief explanation of what my office does. There are some folks who are confused that we're not actually in the traditional acquisition chain, so we'll talk a little bit about what the Air Force Operational Energy Office does. Then I'll hand it over to each one of our speakers to allow them some time to talk about their particular companies and how they are involved in the BWB program. Okay, next slide, please. Oh, how about that? So why operational energy? Why does my office exist? If you look at efforts from 2010 on, operational energy offices in the services stood up primarily in response to challenges with fuel logistics supply chain risk in the places that we were operating out of. Iraq and Afghanistan from 2007 to 2008 experienced a very high number of casualties to logisticians delivering fuel and water to outposts. And the conclusion was that we really didn't have a firm grasp of the fuel logistic and water logistics supply chain risk that we were accepting in those theaters. And so we developed ways to study them better, study technologies better in order to minimize that supply chain risk. Now, in the Air Force, when we think about supply chain risk, we think about it from various theaters that we operate our aircraft out of, one of them being the Pacific. And when you start looking at how we operate in comparison to other services, aviation fuel is a large part of our total energy budget. And the risk that we see in certain scenarios is quite high. So developing new technologies to address that are really important to us. The office itself, when we talk about our mission, we talk about it enhancing combat capability for our crews. We also use the term enhancing lethality per gallon of the assets that we operate. And so we talk about this because in the past there has been some skepticism as to whether efficiency is really important in the way we execute our mission, and we've seen that it's highly important, and that in many scenarios that if we don't focus on efficiency more than we have in the past, that we will have complications in delivering fuel and delivering mission to certain locations. So you can see from there, we just talk about increased lifespan, lowering sustainment costs, increased readiness. These are all factors that we think about in operational energy. This is just a quick slide to show you a couple different things that we've worked on in the past. You'll see the C-17 with some drag reduction microvanes is what we call them. We've currently installed it on 10 aircraft in the Air Force, and we're getting ready to install all 222 with these microvanes within the next year. We also do other novel things like vertical windshield wipers. We're actually doing some work with Delta on vertical windshield wipers because we have KC-135s that look a lot like the front end of a Boeing 737, and they have 767s that look a lot like the front end of a KC-46. So there are times when we will pair with an airline or a company that has a technology that we think we can take advantage of. You'll see that guy in the middle there. That's before 2018, the execution of our mission was really done in some locations like Al-Udeid Air Base, where that's taken from dry erase markers and magnets on whiteboards, as opposed to doing it digitally. And that transformation to digital has resulted for us in quite significant fuel savings, as well as, if you have a better allocation of your assets in a location, or more effective use of them, then that means that perhaps you can deliver more combat air power in that one particular location, or you can move some of that combat air power to somewhere else in the world to deal with whatever issue that we're dealing with. And we saw in that one particular case that just a simple modification to the code allowed about a 4% improvement, and that adding some intelligence to that through AI and ML, we were getting close to 20% better. So 20% is a pretty big number when you're talking about the cost of fuel burn, you're talking about the aircraft that you have to have airborne in order to conduct certain missions. We also spent some time on engine modifications as well as just engine improvements. That's mainly on the engine modifications. I would say it's more along the lines of coatings for turbine engines that were not previously coated, and by coating them with certain materials, you can increase the lifespan of that engine and increase the fuel efficiency of that engine. So for us, that's a money savings, that's a sustainment savings that in the past we weren't really taking into account. And then finally, you'll see that one picture there that says the Airlift and Tanker Association Awards presentation. What we discovered is that a lot of the operators, and I was a former operator in the AWACS, for example, at Kadena Air Base in Japan, I really didn't concentrate much on how we burned fuel. We concentrated more on how we executed the mission. which is fine, but that does tend to drive the perception that fuel is free. And since fuel is such a big cost for the Department of Defense, we felt that making that, incentivizing that behavior could potentially result in a reduction in fuel usage and then a changing of mindset in certain folks that we felt needed to understand the differences in how we were going to execute the mission in the Pacific as compared to, like, let's say, in the Middle East and LUD Air Base. We've since moved that particular program to like 59 squadrons in Air Mobility Command almost exclusively, and we've seen pretty significant savings. We're expecting around $60 million this year just by having crews think about fuel more. They get awards and rebates at the end of the year, not the crews themselves, but the wing commanders, who tend to have very little discretionary budgets, so they're very enthusiastic to participate in this program. And for us, it allows us to save fuel during the year of execution. Then we also have a program that allows us to recoup fuel money that has expired. So that'll allow us to build this, what we call, virtuous cycle of technology investment that results in fuel savings, that results in us reinvesting in new technologies to further enhance the efficiency of Air Force platforms. And this gives you an idea. From any year, it could be from 5 to 8 million, or excuse me, 8 billion. In the past, 2010 to 2012 timeframe, it rose as high as $12 billion a year. So it's a pretty big part of our budget. And we're confident, based off of what we've seen over the past few years, that we can get into the triple digits of savings just by both process and by technology in primarily our large platforms. And that money will be reinvested and be a better use of the taxpayers' money as opposed to coming out the tailpipes of our aircraft. Just a few examples of the efficiency gains that we've seen recently. Since 2019, we cost avoided last year, or actually in 23, about $124 million in our 4 major platforms: C-17s, KC-135s, C-5s, and C-130s. And we did that through a variety of different ways. Some of it is engine modification, but some of it has been through behavioral modification, better routes, better planning, carrying less fuel. All those things have resulted in us seeing these triple-digit million savings. And that really was just basically on a fuel burn per flight hour basis. So if you compared the fuel burn per flight hour in 2019 of those major platforms and what it's doing now, that savings was realized in that manner. And you can see on the C-17, part of it is behavioral, but part of it is things like those microvanes and engine washes and whatnot. On the KC-135, a lot of it was behavioral. And on the C-130, there's actually been some modifications to our legacy C-130s that helped contribute a lot to that, modifications to the engines. But along the same lines, we have aerodynamic modifications in process right now. And this is our pitch for the BWB. We think it's a transformational capability, transformational design. And for us, it'll allow us to operate with additional combat capability from farther away than we have in the past. And that's why we support the development of it, for having that optionality going forward, that as we look in the out years and we're looking to procure new aircraft, whether it's cargo aircraft or ISR aircraft or air refueling aircraft, that additional capability to stay airborne just gives us more options. And it also reduces the amount of fuel that we have to consume from locations in the Pacific that are already going to be challenged with their fuel supplies. Just a simple, this is what 30% efficiency gives you in aerodynamic efficiency, gives you in combat capability. As you stretch out, 4,000 miles is halfway between Guam and Taiwan. That location and the additional fuel that a BWB aircraft could potentially have would be game-changing for us on being able to support fighters at a distance. And for us, this particular demonstrator project is really aligned to a couple things. We're trying to accelerate, and we're constantly working with our partners to accelerate the development of this technology. The quicker we get it figured out, and the quicker we get it airborne, the quicker we can adopt the technology in the Air Force, and the nation could adopt it for commercial uses as well. Part of it is not a all Air Force project. We actually deliberately saw what was going on in private industry and urban air mobility, and we said to ourselves, that type of public-private partnership for us was really important to use in this one particular development of this platform. When we show this, we talk a lot about our previous platforms. A lot of our previous tanker platforms and cargo platforms have been based off of commercial designs, some of them that were developed at the same time. For example, the KC-135 was developed at the same time as the Boeing 707, and it was really that Dash 80 getting airborne and people seeing the capability that drove Wantrip and Colonel Slemay to both buy into the technology. And so we've seen that with the amount of investment that was going into urban air mobility, and we think we can apply that same technology to next generation Air Force aircraft that we need for the future fight. This gives you an idea of this flight path to optionality. We started the DoD investment in 2023, August. We had prior to that, a competition between several different companies to decide which ones we wanted to pick going forward. And then Secretary Kendall in August of 2023 picked JetZero, and then we went forward with JetZero closing their Series A, and you can see as time has gone on, they've slowly been building up some really powerful partners that are here today to talk about what this technology can do for the government and what it could do for the commercial industry. Last thing that we just recently completed was the critical design review in May, and now they've just announced a factory for the commercial product coming out of North Carolina. So that's the airplane, and that's what we're here to talk about. We look forward to your questions. We have some questions initially after each panelist gets a chance to talk about their particular piece, and happy to hear what your thoughts are going forward. I think that's the last one of my slides. All right. Okay. Let's see, who do we have first? I think it's Mr. De Silva.
I think it's Stan.
Oh, I'm sorry. Yeah, it is Stan. Stan, you're up.
All right, thank you.
Sure.
It's at the end.
Yeah, it's at the end. We need to load the second set of slides, I think. There we go.
There we go. Okay.
All right.
Good afternoon, everyone. So my name is Stan Tran. So I'm on the United Airlines Ventures team, or UAV. I'm going to skip this safe harbor. So if anyone needs a reminder of who United is, I'm going to give a really quick one. United is, from UAV's perspective, where they are a first-class partner for cutting-edge technologies. And the reason we're able to do this is, well, one, we're the largest airline in the world based on ASMs, or available seat miles. We have over 100,000 employees, some of which are helping and supporting us on our technology and investments, such as JetZero. We've got tons of new airplanes on order, including JetZeros, which I'm really excited to say. And of course, we have a really great frequent flyer program. We have the best app in the airline industry. I don't think it's my opinion. I think it's pretty public. Sorry, Delta. And financially, we've done really well this past year, and we were the 4th best performing stock in the S&P 500. So talked about some of our innovative ideas and what we do. So in addition to the app, we're launching Starlink. We've launched it this year in our regional fleet. We have a fund that's associated with the United Airlines Ventures, the Sustainable Flight Fund, where we're actually taking capital from our closest business partners like a Google, like Boeing, like Embraer, to support our mission of reducing the carbon intensity for aviation. And then, of course, our team, the Ventures team, also works really closely with our in-house innovation lab, which is called AirShop. And what they do is they basically test out new technologies, services, ideas that will be used in our operation in the near term. And how do we do this? Even though we have this, they're able to do this despite the fact that we have a 24/7, 365 operation across 6 continents, almost 5,000 flights a day, and the most and the best international route network among the U.S. airlines. So what is UAV? We're the corporate venture capital fund for United Airlines. We're focused on 2 things. So it's what the future of air travel will look like, and how can we do it in a lower carbon intensity manner. So we look at investments in 3 verticals: aerospace, which is where our JetZero investment sits, and I'll talk about it during our moderated discussion of why we invested in JetZero. We've made technology investments as well. These are technologies that add value to the customer experience or operation. And then I spoke a little bit about our energy investments. This is tied to lower carbon and sustainable aviation fuels. Partnering with, from a startup's perspective, partnering with UAV is transformational. We leverage our United brand and our public relations team. They provide that sounding board and audience for these startups. We put these startups in touch with our portfolio companies, with other partners that we frequently talk to and interact with. Working with our airshop team, as I previously mentioned, we facilitate proof of concepts that these companies might, that they're gonna work with and prove out in our operation. And then capital is, I think, from my perspective as a finance person, is one of the most important aspects. And then, of course, our C-suite. Scott Kirby, of course, has made some pretty public comments about a 3rd OEM, and we love to ride off of those coattails as well. These are just some of the accolades. I'm going to skip it because I'm modest. And kind of going back to that C-suite comment, this is the investment team, but I just want everyone to focus on the fact that Mike Leskinen, who's the United CFO, he started United Airlines Ventures, and because of that connection, we have access to our executive team that makes a really big difference in getting that internal support within the company, and also that amplifying that message that these startups have. These are some of the, I know this is mostly an engineering audience, so I'm going to skip some of these financial aspects, but we do put capital at risk in our investments. Our check size is typically around $5 million, and we are a partner. We typically try to partner with a leading Silicon Valley venture capital fund that has the experience in leading rounds and setting valuations for these companies. And we're here because we provide that commercial support and that amplifying voice. And this is just a quick summary of our portfolio. So on top of JetZero, there's a lot of other aerospace startups that you may have seen or heard, like Archer, Boom, Eve, and Zero Avia and Heart. And this is the message from our CFO, again, who's the founder of United Airlines Ventures. I think that's everything. So
Okay, thank you. All right, I think Sangeeta is next.
I'm next.
Yep.
Thank you.
Can we bring up the Delta slides, please?
we can keep these.
There we go. All right. Good afternoon, everyone. I'm Sangeeta Sharma, and I lead the Sustainable Skies Lab at Delta Airlines. I won't explain what Delta Airlines is. I assume most of you have taken a flight on our aircraft in the recent past. We were very fortunate earlier this year to actually celebrate our 100th anniversary. And if you think about what 100 years of operating commercial aircraft mean, it means a lot of expertise. It also means that we're hungry for the next 100 years of aviation. And when we think about what the next 100 years of aviation look like, I think sustainability is a very important aspect of that operation. And so our vision, much like United, much like every other commercial airline, is to deliver a sustainable travel experience, net zero and zero waste to landfill by 2050. Aviation is a hard-to-abate sector. That probably excites a lot of us in this room because we're engineers and we like a challenge. But I think it's important to acknowledge that this is a challenging sector to decarbonize, and that's why we've been very intentional about how we've set up our sustainability strategy as an airline. And what we're really trying to focus on here is what we fly, how we fly, and then the fuel that we use. I'll touch on this at a very high level, but the punchline is today we are really focused on what we fly, JetZero being one of them. But we do pay a lot of attention to short and medium-term action that we can take as well. So in the how we fly section, Mr. Guerrero mentioned a couple of technology partnerships that we're working on installing finlets on our aircraft. We're exploring the potential of riblet application. We've done a lot of work as it relates to en-route flight efficiency and routing. We're also paying attention to the travel experience. If you've boarded a Delta Airlines flight recently, you were probably handed a beverage in a blue paper cup. That is actually the first paper cup in the world to not have a plastic lining at all. And so again, if you think about this hard-to-abate sector and just how many things we need to think about to get to net zero and zero waste. We pay just as much attention to our ground facilities and footprint, as well as the fuel we use. I think it goes without saying that SAF is a very important lever on every airline's journey to net zero. I think what's exciting about the what we fly aspect of our strategy is that if aircraft like JetZero come online, we need less SAF. And so SAF becomes a more attainable goal. So diving into what we fly, again, if you've looked at any airline's what I'll call glide path or path to net zero, a large chunk of our emissions abatement is going to come from natural fleet renewal. But we also think that a good part of this carbon reduction is going to come from transformational technology, what we're calling revolutionary fleet. And so our goal by the end of this year was to have 5 strategic partnerships with revolutionary technology players, one of which is JetZero, and I'll talk a little bit about why we're so excited about JetZero in particular. This puts us in a position to help influence the design and development of this aircraft so that we have flyable aircraft by 2035, 2040, and by 2050 you see our internal targets, 40% fuel efficiency gains based on fleet renewal, 25% due to revolutionary fleet in our aircraft. If we dive a little bit more into the revolutionary fleet space, we established the Sustainable Skies Lab 2 years ago, again, because we realized that the solution set to this problem doesn't exist yet, but we want a seat at the table. We don't make the aircraft that we fly, but we certainly have a lot of opinions as to how it is operated, and so we welcome the opportunity to sit at the table and really voice those opinions. We're here today to talk about JetZero. We also have partnerships with Joby, Airbus in the hydrogen space, and we're about to announce a 5th partnership later this year. You will find out later this year. And so why JetZero? I'll touch on this very briefly. I think we're going to have some question-answer time as well. But really, there are kind of 3 things we're most excited about when it comes to JetZero and influencing the design here. One, the aircraft interior. The new shape of this aircraft gives so much space for our teams to play with, both from delivering a next generation customer experience, but also the employee experience on board. Our flight attendants are so excited about the possibility of delivering service to 12 rows of passengers. Just think about how much more personalized and white glove that can be. From an airport operations perspective, safety and reliability are number one. Stan, you bragged about your app. I'm going to brag about our operation. We have been the most on-time airline for quite some time, and we are very excited about bringing that expertise to this team to build an aircraft that maintains the turn times that really help keep us profitable. And the last thing is, again, that operations ecosystem and reliability. How do you leverage a data-rich ecosystem and kind of a data-first environment to make sure that this is the most reliable aircraft from day one? So I will leave it at that. Again, we are very excited about the work the JetZero team is doing, and we will jump into why later.
Okay. All right, Mr. De Silva's next.
There you go.
Please load up the JetZero presentation. I'm going to stand up front here because I'm the head of a startup company. I actually thought about wearing a black turtleneck with black pants. But in respect for Mr. Guerrero, I kind of went halfway, not wearing a tie, but I am wearing a suit.
Close.
So Dan De Silva, President, COO of JetZero. A lot of what I bring to JetZero comes from that 35 years of aerospace experience where I learned a lot of what not to do. And now we're able to apply that at JetZero. We also learned a lot about what to do. And that's the mix of that experience of startup team members and aerospace experienced team members is what makes JetZero such a special company to work for. I just put this one here as a test, just to make sure everybody here understands what we're talking about, why a blended wing body is better than a tube and wing airplane. And I'm not going to explain it because a better than 50-50 chance you can touch the person next to you and ask them, and they'll explain it to you, especially in this audience, correct? And if you can't find anybody here to explain it, we're in the wrong place. But the reality is the tube and wing is the shape that started back in the 50s with jet aircraft and has remained pretty much the same until today. The efficiency of that particular shape has been explored and improved over the years, and the industry has done a tremendous job in improving the fuel efficiency per seat mile of the tube and wing airplane. However, we've achieved probably the limits of the physics of those improvements. Jet engines have gotten better, aero has gotten better, CFD has helped, but nothing beats the first principle physics of having a very well distributed lift across the span of the airplane. And that helps with structural efficiency, that helps with creating more lift and reducing drag of that airplane. The whole airplane provides lift from wingtip to twin tip, which then makes it a lot easier to build a structure that is more efficient across the span of the airplane. Where are we today? Mr. Guerrero showed a little bit of our program earlier on, but we just delivered critical design review to what we call our government customer, because it's not just Mr. Guerrero's group, it is an entire set of government representatives with consultants and partners, some of whom are in this room, from Georgia Tech to NASA to AFRL, and several members of the government team that come and inspect what we do on a regular basis. Critical design review was one of those most important milestones where the entire design concept of the airplane is ready. From that moment on, we're on to building this airplane. Who's building this airplane for us? We've partnered with Scaled Composites, and Greg is here to talk a little bit more about that. And Scaled is the premier company out there in building prototype aircraft. What they've done, how they've done it, how fast they do it, is a very simple explanation of why we picked Scaled as a partner to build the demonstrator for us. You can see here a few of the pictures of where we are in that journey of building this airplane. We've built a wing test article. It's now actually located in our facility in Long Beach. Greg can explain why we built that. We were trying to match theory with practice and calibrating our FEM models. But right now we're working on the cockpit pressure vessel, which is the only part of the airplane that will be pressurized, and starting to build tooling for the center body of the aircraft. But we're not going to build just one airplane. The whole idea of launching JetZero is to get to a third large aircraft OEM around the world. So we only can do that if you figure out how to make airplanes in a more efficient manner, and you can figure out how to do it in a cheaper, faster production facility. With that, we announced in June that we're going to build the factory of the future in Greensboro, North Carolina. What you see here is about a 5 million square foot facility, and we're going to build our first commercial airplane, the Z4, at this new facility. We have partnerships with Siemens that is helping us create an entire digital environment where we're going to design not just the airplane, but we're going to design the factory and the processes around it using Siemens products. And this factory is going to be able to deliver up to 20 aircraft per month at its full capacity. You don't build a commercial airplane unless you have a target market to fit it in. You have to sell it in the end. How many airplanes can you sell? Initially, when we were looking at the old Boeing studies around what Boeing called the NMA, the new middle market aircraft. And it looked like 4,000 to 5,000 airplanes. We hired some consultants to help us, premier consultants in the aerospace business. They looked at it, they looked at our airplane, and they said, no, you're wrong. It's not just 4,000, 5,000 airplanes. Your airplane is so efficient that you're going to be able to cannibalize the top of the narrow body market and the bottom of the wide body market, and your total addressable market is actually much larger. You can capture up to 12,000 units with this very efficient airplane. Does it mean we're going to sell 12,000 airplanes? Very unlikely. But if we win 30% of that market, we can sell up to 4,000 airplanes over a 20-year period. So that's a market worth going after. It's about $2 trillion of total addressable market, which is very easy to build the business case around. With that, I just wanted to spend a moment to thank our partners here, starting with the government customer, the US Air Force, Delta Airlines, United, and Scaled for not just being on this panel, but being partners with us at JetZero. So thank you. And Greg, I'll pass on to you.
Awesome. Thank you very much, Dan. I appreciate it. If we could load Scaled slides as well. I am most assuredly not a startup CEO, so I do have to wear a tie. So I'm going to do that today. Let's go, and we're in Las Vegas today, but let's go to Washington, D.C., and let's go to the National Mall, and we'll understand a bit about why Scaled is involved and so excited in this program. Let's go to the National Mall, and we'll walk into the newly renovated Milestones of Flight Gallery at the Air and Space Museum. And when you get there, you see the Spirit of St. Louis, you see the Wright Flyer, you see the Bell X-1, you see an X-15, you see the Apollo 11 command module, and then you see Spaceship One hanging from the ceiling, the first private spacecraft, designed, built, and tested by Scaled in Mojave just over 20 years ago now. We love milestones. We like taking these dreams, pushing the boundaries of aerospace, and making that next big thing. When I say big, sometimes I literally mean the biggest in the case of Stratolaunch, which we also built, the world's largest aircraft by wingspan. If we leave the National Mall and then we go to the Udvar Hazy Center out by Dulles, you'll see Global Flyer hanging from the ceiling, which took off from Florida and landed in England, which doesn't sound very impressive until you remember it took off from Florida. Steve Fawcett did it once around the world, and then continued to land in England from there. If you talk to John Kruger, one of our crew chiefs who worked that program, that was a fascinatingly challenging program we'll talk about in a little bit, because it obviously had our lowest safety factor of an aircraft designed, right? I don't want to re-hack the Brugge range equation to everybody in this room. I'm sure, as Dan said, you're all quite familiar. But fuel fraction is the driver for range. that aircraft had a shocking fuel fraction. Off the top of my head, I believe it was 84%, but I think Wikipedia will probably correct me on that. If not, I will edit Wikipedia tonight to make sure that's what the number works out to be. But John tells a story in the middle of flight test about going in and sending a single ply of composite out of the fuel tank because analysis determined that we didn't actually need that single ply, and that was going to save some weight. And then Proteus, which we're still flying today. I've got some good core memories after making left turns over R2515 over Edwards all night, watching the sunrise from 50,000 feet in that airplane. So still doing great work today. Scaled is, I would argue, we punch far above our weight class. I'm, again, incredibly biased, but we have 321 employees working 20 active programs at a given time across 300,000 square feet of buildings in Mojave. Scaled has been in business for 43 years, and we have more than 43 new aircraft designed, built, and tested. And we are expanding for JetZero. We're incredibly excited about this program. As we talked about and Dan mentioned, we're building parts, and we're going to be looking forward to flying this airplane. Some of the aircraft we have flown are here. You notice this does not add up to 43. There's plenty we can't talk about as well. But Scaled has been working to push these boundaries of aerospace for its entire history. We talk about going fast, and for Scaled, typically this means for a typical trainer-sized aircraft about 2 years from contract signing to first flight. And again, this is contract signing to first flight of a new clean sheet aircraft. The Swift, which was originally going to be a TX contender, was about 30 months from contract signing to first flight, slightly more complicated aircraft than we see. That was an F404 engine, ejection seat, transonic hydraulic flight control aircraft. Global Flyer, a little bit longer development, again at 25 months, because that additional analysis required to get that range and make sure we could meet our core requirements of that aircraft. The Model 401s, still doing great work today, 24 months contract signing to first flight. The Model 437 we called Vanguard, 21 months from contract signing to first flight. Old School, or the Firebird demonstrator, 12 months contract signing to first flight. And our build of X47A, 5 months on the build. We do this in this way. When I first joined Scaled back in March of 2023, I was incredibly excited to learn what is the secret. I will share that when I graduated from engineering school in 2004, I sent one resume to one company for an engineering job. It was to Scaled. I did not get an interview, much less actually. So they just looked at my resume, said, this guy's useless, and immediately trashed that. The joke now in the company is if you wait 19 years, you get to run it. So we'll see in about 19 more years if that's true or not. But what do? This slide used to say minimize requirements, and I actually disagree with that. We don't minimize requirements, we tailor requirements. We work with our customers to help understand where are the inflection points in cost and schedule. What is your core driving requirement of your program, and how do we work together to make sure you achieve that as efficiently as possible? So we want to tailor requirements. We don't like programs where requirements get lobbed over the fence. We have to lob an airplane back. We want to work collaboratively with our customers, and we have that great relationship with JetZero. We minimize our team size. We put a small team co-located in Mojave. Now, why I say in Mojave? Because there's nothing else to do in Mojave except build airplanes, so it's exactly the right place to do this, right? We minimize tooling, and this is one thing that's interesting. One thing we really hire for aggressively at Scaled is generalist engineers. And you think, why do you want generalists? And the core of your engineering group is generalists. Because an aircraft is all compromise, right? The classic saying, which I actually learned from JetZero's CTO, Mark Page, when he was my aircraft design professor during my undergraduate. Luckily, he does not remember me. I was not an outstanding student, probably related to not getting that call back for that interview at Scaled. But we have a picture of Stratolaunch here, and we have a flat side on the side of the vehicle, right? There's no structural reason, there's no aero reason why you want that to be flat. But what it lets you do is lay that up on a table. You don't need to make that a tooled surface. And that means that you don't need to incur the cost of tooling that, and you can lay that up just that much faster. We'd find that 80% solution, that best value for our customer to get to those core driving requirements and achieve those as rapidly as possible on a demonstrator. And then our teams work overlapping design, build, and test phases. And this is, if there's a secret to Scaled, it's that. It's that ability to efficiently and effectively work that overlapping concurrent design, build, and test. One of my favorite examples of this was last summer. I was giving a tour of Hangar 75 at Scaled, and the Model 437 was a couple months away from first flight. And I watched one of our engineers, Jake Blozan, pick up, I believe it was a fuel pump, walk out to the airplane and figure out how it was going to get mounted and routed with the A&Ps who were going to do that. That means that that had not been determined yet when we had large aircraft parts constructed. We had space keep-outs, but we didn't know exactly how we were going to do it. But by him being able to go to the physical structure and then work with the people that were actually going to install it, it allowed us to both accelerate schedule and get it right the first time. Our work for JetZero has been continuing. Dan mentioned our wing twist article. I'll expand on that a little bit. The interesting challenge of the blended wing body as a configuration, right, is it is all about aerodynamic efficiency. And that's its core value proposition, right? The mission of the demonstrator is to prove blended wing body aerodynamic efficiency and at scale. And I will say the quiet part out loud, this is a full-scale demonstrator. This is a big airplane. We are incredibly excited about this. That also means, though, that it has much tighter wing twist tolerances than most typical scaled aircraft. So we built the wing twist article to be able to correlate our FEM and be able to make sure that we can achieve those L over D targets with our typical design and engineering methods, which we determine we can. And then Dan showed some layups of the fuel tanks here, which we've got out of Mojave. And we look forward to a whole lot more over the next few months as well as big parts of this airplane start to come together. I'll hand it back over to you, sir.
All right.
And thank you.
Yeah, thanks. I'm actually going to shift my seat here so I can face the panel and grill them with the questions that we have set. So I'm going to give myself a little bit more room. And for those of you who don't know, we'll have a slide up top after we're done with some of the questions that we've already developed so that you can add. And I've got my little iPad here, and I could start using some of your questions as well to make sure that as much as we can do in the time that we have allotted, that we can further dig into the process of developing this aircraft and kind of what we see ahead for the future. All right. So I think I'm going to start with JetZero. Let's see, you've recently completed and passed the critical design review and preparing for subscale and full-scale demonstrator aircraft by 2027. Can you summarize the key technical milestones so far and outline the remaining developmental risks and timelines to experimental certification?
Yeah, thank you, Bert. So critical design review, as I mentioned, was achieved at the end of May. There were a couple of things that were key elements in achieving that point in the design of the aircraft. Finalizing the entire outer mode line of the airplane was one of them. Finishing the integration of the propulsion with the airframe, so PAI, propulsion airframe integration. Getting all the integration of not just the propulsion of the airplane, but also the control surfaces to the structure of the airplane was another key. So achieving all those design elements and delivering most of them to scale so they can start building parts was one key step in getting our program to move forward. From this point on, and here's one of the things that Greg was mentioning, the flexibility of working with Scaled is we had a plan, and we were going to build the airplane in a certain sequence, and then we had a few challenges. We had challenges in the facilities availability. We had challenges in when we finalized some of those design elements of the airplane, and we just got together with Scaled and quickly flipped the order of building the aircraft. So we're focused first on the cockpit pressure vessel. We're going to do it with a test article and a flight article. That way we can do all the pressurization tests with a test article, and if anything happens, we can incorporate modifications into the flight article. And then from here on out, it's finishing all the internal elements of design of the aircraft. So now we're integrating all the systems. We're going to start having to design wiring, design tubing, and start putting an airplane together hopefully by the end of next year.
Great, thanks. I'll just add that, as we were going down the path of determining how this program was going to be executed, we did visit Scaled. It must have been, I think it was before COVID. And we did that, well, partly because he was founded by Cal Poly graduate, and I'm a Cal Poly Aero graduate, so I'm like, yeah, Burt Rutan. So, but we saw that potential that Scaled had in developing aircraft designs and executing them really quickly, and that was, for us, when it all came around to JetZero getting selected and them picking Scaled Composites to assist them with the build of the aircraft, we were like, this is exactly the fit that we were looking for. So just with that, Greg, I just wanted to ask, why is JetZero's BWB demonstrator a good fit for Scaled Composites in your mind?
Yeah, I very much appreciate that. As I mentioned before, right, we love pushing those boundaries of aerospace. We love being part of that next big thing. And actually, this morning, got a ride on a United A321neo coming here. My family actually still lives in Chicago. I'm in Mojave. And yesterday was my daughter's 11th birthday. Wow. And had a great birthday. And I was telling her, hey, why I was leaving, hey, before she woke up, first flight out, go to Las Vegas. And she said, well, that sounds like a neat airplane. Let me see a picture of it. And so I pulled up a picture of the Z4, of the JetZero aircraft on my phone. And her response was, wow, can I ride in that? I said, Maggie, it's going to be an airliner. Like, so I can ride in that? Yes, absolutely. That excitement, that passion, that spark for the next thing is what convinces people to come build weird airplanes in the desert. That's why Scaled exists, and that's why we're here, and that's why we're so excited about this program. Right? We want to help with that next big thing. I look forward at someday, hopefully, to visiting this airplane, maybe in Dayton, but you're going to have to build a bigger building for it.
We've done that before, so I think we'll continue to do that out there in Dayton. It's an awesome, awesome museum. Yeah, I was just going to say that, you know, just walking through the international terminal at Dulles, you can actually see in one of the kids' playgrounds there a BWB. And yeah, my daughters, when they saw it, they're like, man, that looks like a manta ray. I want to fly in that thing. So the same type of reaction from my kids as well. Dan, back to you, just asking in practical terms, how has that public-private partnership accelerated development? Has it shortened timelines, reduced costs, or improved testing?
Yeah, I can't overstate the value that public-private partnership has to spur the development of a company like JetZero. If you look at the history of almost every aerospace company out there, every single one of them was formed by a public-private partnership. And that's no exception. Even the last startup in aerospace, which was Embraer in Brazil, I happened to work there right out of college. But in 1969, the Brazilian government formed a public-private partnership and offered a 1% tax rebate for any corporation that wanted to invest in Embraer instead of paying the government. So that was one example of public-private partnership dating to 1969. But you know, whether it's through an initial government contract or through direct loans, such as what Airbus got for a lot of the programs they launched, it is an important element of launching a new aerospace company. And for us, it was that extra kick that was necessary in the market to give a small startup in Southern California the credibility to go seek private funds that would then add up to a Series A, and we're hoping to close a Series B here in the next couple of months. And that credibility comes from the belief that the US government has put in the company through a process that was competitive. So it's not like we just walked in there and you said, oh yeah, JetZero, come on over here and we'll give you the program. So that also helped us create the discipline necessary. What we had to do in our submission to your competition has served us well in creating that program management discipline, documentation discipline that we can now show to investors, and they can see that what we do is really follows that aerospace rigor, even though we are still a creative and agile startup company.
I'm going to shift over to Delta and United. The question is, you've each taken different partnership approaches, United via capital investments and conditional purchase agreement, Delta via operational and technical expertise through the Sustainable Skies Lab. How do these models differ in aligning incentives, and what are your hopes and concerns before proceeding with firm orders? We'll start with Delta.
Sure. I think the punchline here is that all of the above is required, right? You need capital, you need the demand signal, and you need the voices at the table to say, hey, this works, this doesn't, this is what I want to see. We were the launch customer for the A220. We did not have the seat at the table there that we did for this. And let me tell you, we learned a lot of lessons being the launch customer for the A220. And so I think we're really excited about the role we're able to play in the design and development of JetZero, because what it means is, hopefully in 2027, we're seeing demonstrated technology, demonstrated fuel reduction that lets us place that order. And when that aircraft enters service, it's an aircraft that is ready to fly day one.
Stan?
Thank you, Mr. Guerrero. So I'll break this question down to 3 answers. So, first, I'll kind of direct everyone back to that slide that I presented, what UAV looks for investments. It's reduce the carbon intensity of the airline and enhance the customer travel experience. There's no singular investment that we've made that accomplishes both objectives like JetZero has, right? 30+% fuel efficiency savings, and this, and as Sangeeta pointed out, this blank canvas in the cabin that allows our commercial and engineering teams to do some incredibly creative things to make the passenger experience better. So that's why we invested. Second is, why do we go down the financial path? And I don't know how this finishes, but money talks and something happens. Capital is a really important consideration in venture capital, right? And there's no stronger demand signal to venture capitalists, to the industry, like putting your capital at risk, cutting a check to JetZero to say, this is real. Like Delta, we have plenty of technical experts and engineers who've helped us UAV diligence the investment from a technical perspective, and we clearly see that there's something real here. On top of that, the financial investment gives us that actual seat at the table, not only as a customer, but as an investor. So we participate in driving some of the more higher level strategic actions that the company will take, who the company should partner with from a venture capital perspective, what product offerings the company should embark, and that's also really exciting, and that's how we can make a big impact. And then, of course, as I mentioned earlier, the third thing is the conditional purchase order. I think to provide some context, venture capitalists typically value a company in early stages based on the revenue potential of the company. And if you think about a conditional purchase order of 100 aircraft plus the 100 options, well, if you take a multiple on that, that's a company that could be worth several $1 billion.
Great, thank you. I was going to ask Greg, just I know some folks are wondering, what is Scaled's future involvement in the production aircraft going forward, and just kind of what your business model is?
Yeah, I appreciate that very much. I think it's a really important distinction. So we have really appreciated the partnership with JetZero on the demonstrator, but the short answer is our involvement in the production aircraft is essentially none, right? Scaled really focuses on demonstrator and prototype production. I look at those, the distinction I draw there is how much traceability to production do you have? Our focus for the JetZero demonstrator is being a demonstrator. We need to prove that blended wing body at scale. As I mentioned, I remember being in Mark Page's aircraft design class and him talking about the blended wing body and the potential of that, right? That would have been 2004, so I've just aged myself there, which is good for everybody. Unfortunately, I know everyone in this room can do math, so it's disappointing. But Our goal is really that singular focus on execute the demonstrator, prove the BWP at scale, and then let the team at JetZero, which is outstanding and has experts in certification, production, moving to those next stages of prototype EMD, and then getting to aircraft delivered to United and Delta.
We feel in the Air Force that piece about getting a full-scale aircraft airborne and demonstrating that efficiency, and that's really what this contract was primarily focused in, is will open up a lot of doors, will change a lot of minds on the viability of this technology going forward, and then you'll see the cogs turning in the heads of people going, what kind of application could I now transition that type of platform to that in the past, they weren't considering that. So,
and Bert, I think one of the things I want to add to that is that, yes, even though the demonstrator is just a technology demonstrator and it's not a prototype for a commercial airplane, it's giving our team a chance to acquire a lot of experience, and the learnings of the process of designing the demonstrator, which is a full-scale airplane. By the way, for those that haven't been paying attention, this is a 184-foot wingspan airplane with 256,000 pounds of max takeoff weight with two 40,000-pound thrust engines. This is not a toy. And the learnings on designing control laws for the demonstrator are going to be directly applicable to the production airplane. The learnings on how to work with suppliers, because we have suppliers that are designing nacelles for us. We have suppliers that are going to be designing exhaust. We have suppliers that are providing commercial off-the-shelf equipment that we have to integrate. All that activity is serving as a laboratory for the team to learn how to work together, learn how to work with suppliers, which is going to accelerate our work into the production airplane.
So what do you see then, Dan, as we know some of the benefits, we've talked about some of the benefits, but what do you see as the challenges and the benefits you're seeing in terms of propulsion efficiency, maintenance access, certification for hurdles going forward for the product?
I'll start with the last, which is certification. We actually started looking at certification not as a barrier, but as an enabler. If you look at certification, certification is a recipe. All the elements are there, the processes are written. It's like, baking a cake. You not only know which ingredients to put in, you know which sequence to put them in and what temperature to bake them into. That allows us to design an airplane to a certification standard. When we went initially to the FAA and we talked to them about this airplane, they actually had a sigh of relief and said, oh, finally somebody designing an airplane that fits squarely into CFR 14 Part 25 transport category airplane. No exceptions, no new rules, no new regulations that need to be created for this airplane to be certified. And by the way, the same applies to the operational certificate, the same applies to the training and the maintenance of the airplane. It all fits on how today's commercial airplanes work. So certification is an enabler. Obviously, lately you've seen established OEMs struggle through the certification process, but there's a lot of baggage there that also we don't carry. The demonstrator will help with the path to certification. It'll make the FAA feel comfortable with flight control laws and how this product in this shape flies before we even build a prototype airplane. So I think that's my answer of certification. Challenges, there's always challenges. If anybody tells you that they've run an airplane program and haven't hit any challenges, they're lying. I spent 33 years at Boeing, and between the Douglas and Boeing years, we faced many challenges along airplane programs. Our propulsion choice is a challenge. We are squarely in the middle between where the new engines tap out in thrust. So if you look at the GTF and the LEAP 1A, they all tap out in the mid-30s. The new engines start in the 60s. and we need engines that are right in between 40 and 45. So propulsion is a challenge for us. We're working with all engine manufacturers to solve that puzzle. We believe we have a viable solution, and we're going to continue to work on it so that we can bring an airplane to market in the early 2030s as the airlines want us to. And I think that's one of the challenges. The other challenge is industrialization, correct? It's, the history is riddled with prototype airplanes that were never manufactured in series. And the reason is it's one problem to solve to build one airplane. It is 1,000 problems to solve to build 1,000 airplanes. And that transition from building one prototype to building up to 20 aircraft a month is probably one of the most challenging things in aerospace. Fortunately, we have the team with the experience that have done it many times, and we're preparing ourselves to that journey.
Next question is for Delta. Like for us in the Air Force, one of the biggest draws that I talked about earlier was this 30% increase in aerodynamic efficiency for us really dramatically improves our potential lethality per gallon, be able to deliver missions at longer distances and deliver more fuel or cargo to places that we couldn't reach beforehand. We've also had the privilege of working with you all and Delta Tech Ops on several initiatives, and we really are appreciative of that. From a Sustainable Skies Lab perspective, what do you see as the biggest operational benefits of the BWB for Delta and what your mission is?
Yeah, I think it's multifold. So again, that fuel savings benefit cannot be overstated. I think that's what excites us the most, but not just from a sustainability lens. If I wore my fleet strategy or network strategy lens, this is still a very exciting aircraft. How many of us have flown on a refurbished 757? Mm-hmm. Everybody, because there's not a good replacement for that aircraft on the market. The Z4 will be. And so I think just from a classic network fleet fit, this is exciting. From a sustainability angle, this is exciting. And then again, I alluded to this, but if we think about what the next century of flight looks like and how we think about delivering personalized attention to our passengers, a shape like the BWB enables so much because you have potentially a centralized galley for your flight attendants to work out of. You have only 12 rows of passengers to then have those customer-employee interactions. And so I think what we've found is based on some initial content we've put out on social media and the like, our customers are really excited about the possibility of flying on a JetZero, but equally our employees are just as excited about potentially working on a JetZero.
Yeah, we joke that the fuel burn is what brings people into the hangar. The cabin design and the cabin mock-up is what makes them stay. It's really the opportunities that it offers to an airline to completely revamp how you think about aircraft interiors is really great.
Kind of shifting gears a little bit, but along the same theme for United. We've heard you message, United General message about their vision to decommoditize passenger air travel. Your CFO has also recently posted about this on Facebook when he commended your CEO for his leadership. Can you explain this concept and how the BWB supports it?
Yeah, I would say first, I think Delta, and I'll be highly complimentary here, started this whole initiative towards decommoditizing travel, making the travel experience, frankly, better for our customers. I'll take it even one step further on some of the things you said. I think you board a Delta. I don't fly Delta. I think if you board a Delta flight today and you look at the cabin, everything is consistent. The sidewalls of the aircraft are all, that's that bright white that's very inviting, the Delta blue and red that is consistent within the cabin, the seat back at every seat, That experience is something customers want, And we at United are offering the same experience on our aircraft today with Starlink, with power at every seat, with Bluetooth connectivity at every seat. And the vision is to create this living room in the sky experience where you can stream content on board through Starlink. You can watch whatever movies you have. We have a really deep content library on our seat backs. I won't talk about the food because I know everyone complains about the food, but that's hard to change, believe me. But that experience is something that customers have shown in the past several years they're willing to pay a premium for. And then when you layer on top, if you live in one of our hub cities, which is most Americans today live in one of our hub cities, you have access to the best schedule, bar none. You can get almost anywhere in the world on United Airlines from one of our hubs, nonstop. And that is, that's an experience that is worth a premium.
Back to you, Dan. You recently announced your plans to build a state-of-the-art manufacturing facility in Greensboro, North Carolina. What are the biggest supply chain, workforce, regulatory challenges you anticipate, and how is your partnership with North Carolina structured to address them?
First thing I'll say is what the process was like to end up in North Carolina. It was a 16-month-long process with the help of a specialized company called Savills, a great partner to us over that period of time. And at the time, I had a couple of discussions with our CEO about how we would go about doing site selection. And he said, well, we did it by ourselves at Tesla. We don't need help. I'm like, well, this is a little bit more complex. We're gonna have to put together a workforce of, at the time, over 10,000 was what I had in mind, over 10,000 people with specialized skills, of which many are engineers. We have to worry about availability of specialized labor. We have to worry about the availability of power, the availability of water, waste disposal, road infrastructure, overpasses, how we're going to bring parts in. Are we going to fly them in? Are we going to rail them? Are we going to bring them through ports? There's no way we can do that analysis all on our own. So that analysis led us to starting with about 24 locations in 13 different states, which then narrowed down to three locations in 3 states. And the selection in North Carolina had a lot to do with what they offered in terms of partnership for workforce development, what their university their university ecosystem was able to offer in terms of specialized labor and training, and obviously, in the end, the incentive package that they put together for us. But it is truly a partnership, and the government of North Carolina showed that it was not just about us working against each other. It was like, how do we get this to work together? And that was what led us to where we're at.
I guess the next question kind of goes towards certification process, and really I'd like to start with Greg and maybe move this way if any of you have things that you'd like to specifically hone in on. But we're seeing new platforms being developed, and there's a certification process that will happen. You all are experts at new, unique type of novel airframes that you've developed in the past. So looking ahead of entry into service in the 2030s, how do you view regulatory and certification readiness for novel airframes, new evacuation procedures, operational procedures like training, ground infrastructure, and community acceptance changing?
Yes, if I start, I think the demonstrator will be certified with an experimental experimental research and development certification. Mm-hmm. But having a flying aircraft, having an aircraft to get the FAA hands-on, demonstrate things with is incredibly valuable. So I think it's an additive force, really a force multiplier as you go through that certification process. You're not asking to certify on paper. You can have those early conversations that Dan was speaking of to be able to prove that, hey, this concept works, it's out there flying, and if there are concerns, you can address them, especially when you can provide real flight test data to show that, hey, on the demonstrator, this is already solved. We can do this. That is a huge risk reducer and can accelerate that process significantly.
Stan, do you have anything to add to that? No? Stan, did you have anything to add to that at all? Yeah, not really. No?
I think that pretty much covers it. But what I'll say is, again, with the partnership that JetZero has established with all the major airlines, I'm expecting that we'll bring in subject matter experts to support, just like the 777 program. United and Boeing work pretty closely together, and that was an incredibly successful aircraft.
I mean, just by seeing the way the design is laid out and the cabin's laid out, I would think that there are areas of advantage for loading and unloading passengers that might be desirable to you all. Sangeeta, do you want to talk about that at all?
Yeah, I think some preliminary modeling shows pretty fast boarding and deplaning times, which is really exciting from a turnaround and kind of ground processes perspective. I think we still have a lot to figure out when it comes to de-icing the aircraft, when it comes to exactly how you load different parts of it. But those are things that we're excited to figure out. And I think, listen, across the industry, safety is first and foremost, right? And so I think certification is important because it enables that safe operation of the aircraft, and we're here to support that. I'm an ops gal, not a finance person, but I think when you're thinking about where you invest your time or your money or your resources, you think as much about the technologies you're investing in as the people. And I think what makes us very excited about JetZero is the group of people that are building and certifying this aircraft.
Yeah.
I already talked about certification. I'll just add that one question that we get very often is like, how do you evacuate a blended wing body? Aren't there problems to evacuate the blended wing bodies? And that might be true in very large blended wing body designs, which is what we were working at Boeing when I was there. 650, actually the smallest one was 450 passengers in 3 classes, all the way up to 800. There are some challenges you have to have like aft ramps in the middle of the airplane and kind of mid-cabin cross aisles. But at our size, we've done simulations with help from University of Greenwich, and we passed with flying colors. That is just simple 3 Type A doors on each side of the airplane.
I'm going to go ahead and transition to some of the questions that the audience has asked. This one, quite popular, is upvoted 24 times, so they really want to hear what you think is the key remaining technology challenges with BWP concepts.
Key technology challenges is producibility of the non-cylindrical pressure vessel. And that's what we dedicate a lot of our time, is on the choice of materials and processes. The solution exists. NASA invested almost half of the $1 billion they spent over the years in building test articles and proving that there's a carbon composite methodology and process that works well as a non-cylindrical pressure vessel. But then you have to take that idea and produce 20 a month. So that's our biggest challenge.
I think the thing that you brought up that I wanted to make sure that I echo, we in the Air Force, my office is a pretty small office. We have used our partners at Air Force Research Labs, at Georgia Tech, at NASA. They gave us our chief engineer for the project, Dr. Faye Collier. We've been really lucky to bring all these various different people in and really take technologies that were developed over the last basically 3 to 4 decades by the folks at NASA, by the folks at Boeing, and trying to bring this thing to life and to get it airborne. So we're very appreciative of that. Greg, do you see any other key technology challenges going forward for getting first flight on a demonstrator in 2027?
I think Dan has really highlighted the key one that we see for the production aircraft. That is something we're intentionally minimizing on the demonstrator. We're just pressurizing the cockpit to allow the aircraft to fly its full envelope. but we don't see any other large technical challenges for there. I think we're
In this last CDR, the several different iterations that I've been able to witness, it's been very impressive that the way your two teams have worked together to identify areas where there's already existing technology that could be adopted that really just cut risk down to the point where we see the design's doable, and we just got to get marching on getting it airborne in 2027. So.
Yeah, it became very simple at this stage in the program. You have the safety objective, which is always number one, and then we're solving for time and schedule, for time and cost, correct? It's like, from now on, it's, races on to fly this airplane in 2027. So once you've deemed a certain design element safe, then we're solving for time and cost.
Yeah, we very much appreciated the partnership with the JetZero team to be able to do exactly that. And it's been a very collaborative process to, again, like I talked about, to help to tailor those requirements and understand what is our core mission here. Let's work to make sure we accomplish that, to solve that time schedule challenge that we all have. But we're excited. It's going to be a great airplane.
Sounds good. We have one here. Let's see, I just saw it a second ago. How does the size, this is for Delta and United, how does the size of the Z4 aircraft passenger load fit in with the business models of Delta and United?
So, we made that 100 aircraft conditional purchase order, and it was very intentional, because if you think about how many 757s, 767s, and a certain number of our 777s, it's about 90 aircraft today that are flying in our fleet. And, I think as Dan had presented in his prepared remarks, it's that middle of market is, there's no airplane out there today. So I think about commercially, as an av geek and an ex-network planner, there's three mission profiles. One is this kind of high volume trunk route, Chicago to Las Vegas as a good example of that, where you need to move a lot of people. And well, if you have this big open cabin, I know you guys market 250, but I'm sure it can fit more than that. I know a lot of folks like to go to Vegas, during their downtime, and that's a perfect seating configuration. And we fly 757-300s today that fit that mission profile. On the other end of the spectrum, we have a very premium configuration on certain number of our 767s. There's only 167 seats. 46 of them are business class seats that we fly to London. And the 767 today is a great platform because it's kind of the Goldilocks size in terms of having that wide body shape, but also at a low cost. And again, the Z4, perfect aircraft for that mission profile, right? Flying across transatlantic. So what I'll end with is, the 787 for United opened up some really great opportunities. We've launched a ton of new routes since that airplane came to market, and we've got a ton in our fleet today. I think 50 plus. I know we're getting deliveries, so I can't keep count. And we're going to launch some really creative routes with that airplane, and I see the same vision with the Z4 across the Atlantic and to South America.
Yeah, I'd echo that. I think, again, having the option for a middle market replacement is something that really excites not just our sustainability team, but our network and our fleet team. Think, again, anything that the 7.5 or the 7.6 really flies today, East Coast transatlantic flying, transcon flying, but we'd be able to deliver that 4-cabin experience that you see on some of the Delta fleet, but not all, across all those routes, which is really exciting. I think there's also potential for performance into hot and high markets, and things that are traditionally ops constrained.
Great. So another one for Delta and United, we'll start with Delta, and it's a question on the high engine placement. Will likely increase maintenance burden. How are Delta and United considering these impacts?
That's exactly why we want a seat at the table during the design and development of this aircraft, right? We want to be able to connect our mechanics who do those engine changes directly to, I see him in the audience, but the engines experts at JetZero, to say, this is what it means for us to pull this thing off. This is what it means to do a walk around. This is what it means to access that engine, to do a change if something goes wrong while that aircraft's at the gate. And let's design for that from the beginning. I think I mentioned de-ice in passing. De-icing is another thing where let's bring the JetZero team out to our Minneapolis and Detroit operations, talk to the folks who are de-icing aircraft day in and day out, and understand what are the constraints today, and let's leverage the opportunity to solve them, right? Not just for this aircraft, but to solve them.
Great, thank you.
I think, United, of course, has all of those same challenges, and I'll echo all of those comments. The one thing I will add is it's not new. Both Delta and United have or had 3 engine aircraft fleets, DC-10, the TriStar, and there was a playbook back then, and I'm confident that we have some really smart people in our tech ops department that can establish procedures working with JetZero to maintain those aircraft once they're in our fleet.
I'll add a quick thing to that, Bert, because I talked about all the things that those of us who have prior aerospace experience brought into JetZero, and one of the learnings that were positive was this involvement of the customer early on in the design process. And we're running what we call an aviation airline working group, and we're up to our 3rd instance of the airline working group, and each one of them is focused on a different area of the airplane. We just had in April one that was focused on propulsion and systems, and a lot of those questions were asked and are now being studied together with the airlines. We had a team that spent a day on the ramp with Delta. We had a team that spent a day with Southwest, all looking at how the airplane is actually operated, how they're maintained, what kind of GSC, ground support equipment, that exists already, and how that's going to affect our design and how we, for example, how Romar designs the removal and replacement of that engine. So, no pressure, Romar.
I know a lot of folks are wondering, so how close are we to first flight of the commercial variant?
First flight of the commercial variant is early 2030s. We haven't set a date. We just nominated a program leader for the Z4, and her first task is to build a very detailed integrated master schedule, so we can actually pinpoint a first flight date. So, but it's right up there. First flight of the demonstrator in 2027, and then we'll lag 2 to 3 years to that.
So I'm being told I got 1 minute left, so I do have one last question, and this is on a lot of folks' minds. What type of modifications are the airports going to need to support BWB aircraft?
Oh, that's easy, 0. No modifications. Fits in today's airport infrastructure.
Well, I want to thank all of you very much for your participation in this and your time, and thank AIAA for hosting this for us. I have some coins to hand out to you all, and just wish you safe travels back home, and thanks for everything you've done to this point to get us to where we are right now. Thanks.
Thank you.